Probably the best place to start when we define our own classes in C# is to see how we define a class before we can start using them. So we're going to take a look here at how to define a class using C#, and then we're going to take a look at how to use it as we move through the rest of the section. So to define a class in C# you use, surprise, the class keyword. So you say the word class, and then you have to give it a name. In this case, I'm going to use my class. And you can use whatever combination of letters and numbers you want, as long as it starts with a letter and is a valid C# class name. You can't have special characters or anything like that. So I've got class, my class, and then I'm going to define some curly braces, which are going to define the code for this class. Once we've got the class definition laid out here, we can start adding some fields and some methods. You can add fields and methods in whatever order you like. You can define field and then method and then field and then method if you want to. My practice that I use is that I define all the fields up front near the top, and then I put all the methods at the bottom. So let's define some fields. We've got two fields here. One is called my integer, one is called my message. We've got an integer and a string. We could use whatever data types we like. In this case, I've just got a couple for examples. Then I'm going to define a method. And here I've defined a function called myFunction, or method, whatever word you want to use, and it returns an integer. In this case, it returns the myInteger field. So when the code that uses this class calls myFunction, it will simply return the value of myInteger. For the moment, don't pay too much attention to that word public that's in front of the word int. We're going to get into what that means a little bit later in this section. For now, just assume that the word public means we have to put it there so that the rest of the world can see this function. This is pretty much a complete class definition. We could just stop here if we wanted to, but it's customary in C# to define what's called a constructor. A constructor function has the same name as the class. So to define the constructor, you can see I've done that here. I've got a method called myClass. And in this case, this method is taking a string argument, which uses the value of the argument to set the initial value of the myMessageMember field. And again, I've got the word public in front of it, and I don't want you to pay too much attention to that right now. We will get into that. But what I've done here is define what's called a constructor. And the constructor takes the same name as the class itself, and you can give it however many arguments you want, or you can give it no arguments at all. Now, if you don't define a constructor, the C#.NET framework will automatically put one in for you. But it is customary to define one because you use constructors all the time to initialize the value of class fields. So now that we've done that, we can go ahead and take a look at how we might create and use an object using a class that we've defined. So in C#, the way that you create, or to use object-oriented terms, instantiate an object, is to use the keyword new. And it's an operator, so the way that you do this is you use the type of my class, and that's the class that we defined earlier. Then you give it a variable name, myObj. So here, instead of saying int and then some myInteger, which is a built-in C#.NET type, we're using the type that we've defined called myClass. And we've got a variable called myObj. And then we simply say equals new myClass. And in this case, we're passing in a string to the constructor function. This is how the constructor gets called. So that string will become the initial value of that myMessage field. To use the fields and methods of a class that you've instantiated, you use the dot operator. And again, we've seen this throughout the course so far, but let's just make it official. So let's imagine I have an integer called myResult, and this is some variable I've created. I can then refer to the methods or fields of the object by using the dot notation. So in this case, I'm calling some imaginary function called add numbers on my object. Now we haven't defined it yet, but we could. And you can see it takes two arguments and then it returns an integer result. So you use the dot operator to reference the fields and methods of the class. Classes can also have special members called static members. Static members don't require you to create or instantiate an object's instance in order to use them. That may sound kind of weird, but we've actually seen this throughout the course so far. Every time we've used the console object, for example, you notice that we haven't had to say new console. We simply use the name of the class, which is console, and then dot, and then the word writeLine. So we're calling what's called a static, in this case, a member method called writeLine, and it belongs to the entire class. You don't have to have it be part of a specific instance of that class. So let's take a look at the difference between instance members and static members. instance members of a class, whether it's a field or a method, get copied each time a new object is created. Static members, however, belong to the entire class, and there's only one of them. So let's take a look at an example. Let's imagine we had a class that defines the notion of a bottle of wine. For each bottle of wine, you're going to have something like a year and a name to go along with it, and you'd have a constructor function that looks something like this, where when you create a new instance of the wine bottle, you'll pass in the name and the year. But suppose we wanted to keep track of how many bottles we had in our cellar. Well, it seems a little silly for each instance of the wine class to keep track of its own bottle count. We only need one variable to do that. So we would have a static member called bottle count. And in this case, bottle count belongs to the entire wine class. And each instance of the wine bottle will be able to reference this member, but it doesn't belong to any one of them. It belongs to the entire class. So here in the constructor, we don't need to refer to it using the class name because we're in the constructor for the class. But if we were using code that was outside the class, again, think back to the console.writeLine example, we would simply put the name of the class in front of the function, and that says to the C# compiler, hey, I'm calling the static member called this function or whatever it is. In this case, it's not a function at all. It's a member variable. And I'm referring to the variable that belongs to the entire class. So let's take a look at some code that makes all this work, and then it will become a little bit clearer. So over here in C# Express, I've got my defining a class example open. I've also got my example snippets.txt file open, and I've scrolled down to the defining a class section. So I'm going to start off by copying some of this code over. So let's copy over the class definition, just these few lines right here. And the nice thing about C# is you can put the code anywhere in the class file. Now I could make a separate file to contain the wine class, but we'll do that a little bit later. For now, in this example, I'm going to have the two classes be in the same file. So now we've defined the class called myClass, and we've got a couple of members here. We have an integer and a string member, and you can see that we've declared a static integer called myStaticInt. And again, don't worry about that public keyword for now. We'll just get to that a little bit later. Okay, let's go back over here, and let's copy over the functions. And we'll put those in the class. So now we have a complete class definition. We have our member variables. We have a function called myFunction, which returns an integer. In this case, it's the myInteger member. And we have the myClass constructor. And we call the myClass constructor, we're initializing the values of myInteger and myMessage to some initial values. And we also have the myStaticInt, which is being initialized to the value of 100. So now let's copy some code over that actually exercises the class and see what happens. I'll just copy these lines right here. We'll scroll down to the main function and put them in. So let's take a look at the code and see what's happening. The first thing that we're doing right here on line 30 is we're instantiating a new instance of the myClass object. And once we've done that, we can then use the various members of the class. So on line 32, you can see that we're using the console to write out the results of myFunction. And in this case, we're using the instance, which is the myC variable, to call the myFunction member function. And then the next line, line 33, we're going to use the static member. But instead of using the myC variable, we're going to use the myClass name because it's a static member and we need to refer to it on the class name itself. So we're going to go ahead and build and run this. And what we should see is the result of calling myFunction. Let's just scroll back up here. So myFunction is going to return myInteger, which you can see on line 21 is being initialized to 50. And then we have the value of myStaticInt, which is 100. So let's go ahead and run this. And you can see that the results of calling myFunction is 50, and using the static member is 100. Let's go back to the code. Using this example, you can see how we've defined member variables, which are both local to the instance of an object, and the static member, which belongs to the entire class, and we've seen how to define and instantiate a new class using the new operator. As we move through the rest of the course, we'll be doing a lot more of this.